ஆடியோ ஆன் பண்ணிட்டீங்களா? ஓகே. அனைவருக்கும் இனிய காலை வணக்கம். Very good morning to all. Today is the birth anniversary of Nobel Laureate Albert Einstein, sir. On this occasion, the Puducherry Council for Science and Technology is organizing a webinar on Albert Einstein and his contributions to physics and overview. At this juncture, on behalf of our Department of Science, Technology and Environment, and our Director cum Secretary, Madam Smita IAS, I welcome all the participants to the webinar. I welcome our Senior Scientific Officer, Dr. R. Saga Alfred, who will be delivering the keynote address. And it's my privilege in welcoming today's resource person, Dr. T. Rajakumar, retired associate professor in physics. Sir has worked in Kanji Mamunwar PG Center, Bharat Dasan College, and Mahatma Gandhi Government Arts College in various positions. And he is retired as a principal in Mahatma Gandhi Government Arts College, Mahe. Thank you, sir. Thank you for accepting our invitation to deliver today's special talk on today's webinar. I welcome all the officials of my colleagues of the department. Once again, I welcome all. I request all the participants to mute the audio and video. Now I request our Senior Scientific Officer to deliver the keynote address.
Happy morning to all the participants of the webinar, respected resource person, officials, staffs of the Department of Science, Technology and Environment, Puducherry Council for Science and Technology, and all the participants. This Puducherry Council for Science and Technology is organizing this webinar commemorating the 144th birth anniversary of the famous scientist Albert Einstein. And PCS&T is proud to organize this webinar in remembrance of the achievements of this great scientist, who is widely acknowledged to be one of the greatest physicists of all time. A man known for his famous theory of relativity, and he is a man of modern physics who described the dynamics of light and quantum mechanics. He obtained his PhD in physics in the year 1905. And if you see, this year is often known as the year of miracles. And he published 4 groundbreaking papers of significant importance in physics. Everybody is aware of regarding photoelectric effect, Brownian motion, and above all, the theory of special relativity, E equal to mc square. Not only that, together with our Indian scientist Satyendra Bose, they discovered Bose-Einstein condensate, may be called as another state of matter, which is a liquid or gas or solid state, which is widely used in today's technology, lasers and superconductors. A man who has published more than 300 scientific papers, including non-scientific ones also. And his intellectual achievements and originality have made him the great scientist, and the word Einstein as synonymous with genius. And even during his last hour, when a doctor wants to make some surgery on him, and asked if he wanted to have a surgery, Einstein refused and replied, "I want to go when I want to go." Such was his confidence level. And during this occasion, we have a great expert, Dr. T. Rajkumar, retired principal from Mahatma Gandhi Government Arts College, Mahe. Sir, we welcome you. We were really glad to have you today with us. A man with 30 years of teaching experience and publication in national and international journals. Certainly, this webinar is going to be a wonderful session for you, all the participants who have been here to know more about Dr. Sir Albert Einstein. With this, I hand over the platform to the resource person. Sir, for your technical presentation, please. Thank you.
Good morning to all of you. Is it audible? I have a great pleasure in participating in the birth anniversary of the renowned scientist Albert Einstein. At the outset, I would like to thank the member secretary and director, Srimati Smita IAS, Dr. R. Sahaya Alfred, Senior Scientific Officer, Dr. Srinivas Rao, Scientific Officer, Mr. Satish and Mr. Sivakumar. The last two, I know them for many years because after coming here, I see that they were once a student of the college in which I was staff. It is extremely a memorable occasion to be here and to say a few things about Albert Einstein, who is one of the two favorite scientists of mine all through my career. Einstein is one who was dedicated to his entire life to theoretical science, and C.V. Raman to the experimental science. With these few words, I would like to start this lecture, which will be non-mathematical, on Albert Einstein and his contribution to physics. The first part will be a lot of pictures depicting his growth from his child to his very old age. And also I would like to say, it is almost like a synopsis Dr. Saharaj Alfred has given about Einstein and many of his theories. I think he has done a lot of groundwork or homework and got a lot of information also, on which I will be, of course, elaborating and ready to interact or answer any of your doubt to the best possible extent. Now, going into the lecture, Albert Einstein was born on 14th March 1879 in the Kingdom of Persia. And when he was born, his parents were worried. His mother was an accomplished violinist and his father was doing a business of electrical trade. And he was born in the picture you can see in Ulm. Then it was not Germany, it was Prussia. When he was born, it was found that his head was misshaped and he was not talking. His parents were extremely worried. And of course, after a few days, the bump on his head or whatever it is got cured. But he was not able to speak. And he had another sister. Of course, later the parents gave birth to a sister. But for the first 5 years, it is his father. What you see in the picture is the father of Albert Einstein. He was an engineer by profession and he was running a business at Ulm, but it was not successful. Therefore, they moved to a place in Italy called Milan. And but they were Einstein was left behind in Germany to continue his school. These are his parents, his mother, and of course I have taken it from net only. Some of the things you can see: his parents, his mother and father. Next slide. This is the young Einstein on one side, and you will find on the other Einstein and his sister. Now here you will find a compass. Actually, Einstein, many were telling he was not a good student. He failed in the subject and failed in the other subject. But it is not so. Only thing, he was not able to express himself freely, and he had to think a lot before he could express. And once he fell sick, and his father gave him this compass. Not this one, but a similar compass was given to him. And the moment the child got, he was around 5 years or less at the time, the moment he got the compass, he became very curious. He was intrigued what it is going. Always he wanted to change the direction, but it never changed. And in fact, he has mentioned several in his autobiographical notes and elsewhere that this was his first interaction with science or curiosity or intrigue. He wanted to find why it is always in a particular direction, and he was always meddling with that particular instrument. And this is the young Einstein when he was put into school. And at school, he was very good at maths and physics. But when it came to arts or biology, he was not very good. And it so happened, one of the teachers, they were having a rigid pattern just like today. He had to pass all the subjects. And at one time, one of the history teachers asked him, when did Persia defeat this British at the Waterloo? What is the date? And Einstein said, sir, I know that they were defeated, but I don't remember the dates. The teacher asked him, what is this? It is there. It is an important question. Should you not read that? Einstein replied, no, it is all there in the books. If you want, you can just refer in the book. I am not very much particular about information. I am very much particular about knowledge. So even at that time, he was not a poor student, but he was rather a rebellious student. And he wanted to think and come to a conclusion and not just give out information given in the book. So what happened, you will find that this was the first project, means that was the first compass it was given him, and he was enjoying it wherever he was going. And this is a picture of his sister and himself walking through the areas there, exploring it with the compass which his father gave him, with which he was fascinated for several years, you can say. Then what he said, the teacher was very much angry with him and said, you are not fit for this kind of discipline, because the schools, they were expected to produce results, even those days, just like the school of now. So he should be considered more as a sort of independent thinker rather than as a poor student. But many of the books describe that he failed in mathematics, that he was not good at subject. It is not at all so. He was average over all the subjects, but when it came to mathematics and physics, he was excellent, and he had got good scoring. And you will find that even at 15 or 16, he was able to master calculus. You will find the young Einstein, and you will find there that what I have said, he was against memorization of all these things at the school, learning by heart. He wanted to think and he wanted to express ideas, opinions on that. But that was not the school pattern then, and even now it is so. Just now my education pattern has not much changed, probably because there are a lot of students. If you give individual freedom, they will not be able to bring about raise the standard. But anyhow, Einstein was, you can say, a unique person. Though he was not favored and he was not allowed to continue, he never lost interest. Next, say, it was a school in which he studied, where it was a Catholic school. He was born into a Jewish and German family, but he was put in a Catholic school because that was supposed to be the best school there. He's still there. He studied there. And then, of course, he switched over. His father and parents, because of business laws, they switched over to Milan. And he switched over to, for some time, he was there in the school. And then, during those days, conscription was very essential. And at a particular time, he was forced to join. You had to join the army. He was not interested. So what Einstein did was that he got a medical certificate, and at that particular time he renounced the German citizenship. And when his parents moved to Italy, he was put in a school at Switzerland, at Zurich, and that is a picture of the school you are seeing here. And this is a school, it's called a Polytechnic. And here, at first, he was not able to get admission because of his poor performance in biology and arts. But later, he had a second sitting and he was able to get through and he was admitted into the school. And you will find that the school in which he studied was very good, and he continued to be there. And in fact, from that polytechnic, Zurich Federal Polytechnic, they call, he was able to graduate and get a license for teaching physics and mathematics. He was qualified to be a teacher, and he got that certificate from the school. But at that time, he was not able to get any job immediately. As he was not able to get a job immediately, the picture you see now is the patent office. It is at the patent office he worked as a clerk, patent clerk. So many innovations and inventions were there. They were sent, and for copyright purpose, they had to examine it. And he was doing that patent innovation values. He was evaluating it and putting up the file. He was a clerk there. Here there's a comparison. Even our famous mathematician Ramanujam, he was a clerk at port office at Chennai, but he was continuing his research activity because of his love of maths. Here also Einstein, though he could not get a teaching job for which he was qualified to run his family, he had to be there. And you will find in the corresponding period of time, when he was studying in the Polytechnic, there was only one girl, a Serbian girl, and you will find the picture of that student, is only girl student of that particular course. She was also very good and in the subject, and it is widely believed that she helped him in the early days in formulating all his theories and doing paperwork for Einstein. Later they got married, and it lasted up to nearly 20 years. 1919 they were married, and he divorced her in 1919. And during this period, when he was a patent clerk, as a scientific officer said, in the year 1905, he published 4 papers, a series of 4 papers, one on Brownian motion, one on theory of relativity, one on mass energy equivalence, and one on the laws of photoelectric effect, all while he was working in the patent office as a clerk. And it is, of course, a very important year for Einstein. Just a few slides, there will be that paper, all the 4 papers. Click on it. Go on clicking. Front. And all the 4 papers with details. Front. Slide sorter போட்டீங்கன்னா வராது. இல்ல இது இல்ல, பேக்ல போனேன். அது வந்து ஸ்க்ரோல் பண்ணீங்கன்னா you will find here it is supposed to be the peak year for Einstein. அதுதான் அந்த பட்டி அதான். It's very small. இதை வந்து enlarge பண்ண முடியும். You will find the details of all the 4 papers which he did. I got it, of course, from Wikipedia. You will find that all the 4 papers, of course, throughout his period he was working, he was able to publish all the 4 papers. And all the 4 papers were extremely important, and you can say almost it is the peak performance of Einstein. All the other performance, all his other publications are only a follow-up of this particular 4 papers. If you are not able to see that, well, you can find that it is in the Wikipedia. I got it only from that. What is the name of the paper, when it was published, when it was done. And in that, you will find the first paper will be regarding the Brownian motion. That is a classical theory. You will find that long back it was there, and all the particles are in a random motion. And how to describe that random motion, the movement and analysis and study of the energy and all their related parameters. Relating that, he had published a paper. That motion was called as Brownian motion because it was observed through a microscope by a person belonging to biology. In a microscope, when he was suspending some particles, he was able to find that it was always in a random motion. That random motion, how it was there, why it was there, and what is the energy, to arrive all the details, the theory part of it was given by Einstein. And it was for one of the reasons for which he got Nobel Prize. And another one of the four you will find, another one will be regarding photoelectric effect. Photoelectric effect was discovered by some other person. As you all know, Einstein being a theoretician, he never did any scientific work in the lab, or he never worked in the lab except once, except for one which I'll tell later. All his works were theoretical, just calculation, paper and pencil. He has often said that if you are giving me a chance to work, I will be preferring a tower or a a lonely place. I require only pencil and paper and nothing else. I will even prefer a lighthouse where nobody will come. All day I'll be sitting and doing. That is in his own words he has said. So like that, he was able to describe, or he was able to give a theory for that photoelectric effect. What is this photoelectric effect? When light is falling on certain materials, say for example sodium, when white light is falling or ultraviolet is falling, you will find that immediately light will be emitted or photons will be coming out of it. So that is called as the photoelectric effect. Now here, why it is so important, or what for it is considered crucial theory, you will find light was considered to be waves. But when it is hitting a solid surface, it is able to interact with it and a particle is coming out. Electron is being emitted. Electron is considered a particle. During that time, along that same period, another theory called quantum theory was there. And quantum theory predicted that energy is being quantized. And another scientist by name Louis de Broglie had said that every matter has got a wave associated with it. So for all these theories, prediction, this photoelectric effect is a proof. It was observed experimentally, but they have to give a theory. Einstein was able to give a very excellent, simple theory applying quantum mechanics. That is called Einstein's photoelectric equation, and that is a famous equation, and in fact, he was awarded Nobel Prize in 1921 only for that. The Nobel Committee did not accept his relativity theory. Either at that 1905, it was only special theory. I will come to about it later. The Nobel Prize Committee did not accept it. They were still in doubt whether it is correct or not. But regarding this photoelectric effect, the laws of photoelectric effect, there are three laws. He was able to explain all the three laws, experimentally discovered law by his applying quantum mechanics. So he was awarded for his extremely intelligent application of quantum mechanics to that particular experiment, and the Nobel Prize was awarded only for that. It was awarded in 1921, and again there is a certain story behind it. He was not able to receive it in person, and he wanted relativity theory to be mentioned in that for one of his achievements, because he thought that was his pet theory and it is a very valid one he was believing, but the Nobel Committee did not accept it. So for some time, actually in 21 World War I was going on, he was on a lecture tour probably in Japan, and he couldn't go and accept it in person. But then what he thought, whether to accept or not. Luckily, as he was away, he could not accept. But other compulsions and other persons said that you have to accept it, because he was nominated for that award nearly 6 to 7 times even earlier. But that time the Nobel Committee did not consider it. But considering the 1905 photoelectric effect and Brownian explanation of Einstein's theory, they said he is a recognized scientist, he has to be accepted and awarded. So in between, actually, in 1915, he published general theory, but nobody understood that, nor they were able to understand the theory of relativity. So they thought it is safe to give on him, and he also thought it is better we should accept, and he accepted it for the single reason, because when he divorced his first wife, his entire proceeds, not even a single pound or dollar he took, the entire Nobel Prize money went to his first wife as a divorce settlement, so that she will use that amount to look after his two sons. He had two sons through his first wife, and of course they were his only son. Second son, he was his relative, he didn't have issues through that. So for the welfare of his son and as a divorce settlement, the entire prize money was that is why they say there was a news at that time, you have a scientist who never touched a single paisa of the Nobel Prize money, but it was given to his first wife to look after his two sons. And his two sons, பின்னாடி போங்க, ஃப்ரண்ட் அங்க இருக்கும் டூ சன், இதுக்கு முன்னாடி இன்னும் முன்ன போங்க, you will find his first wife and his two sons. Actually, they were together for around 19 or 20 years. And because he was always immersed in his scientific research, he was not a very good. You have to remember the enormous amount of work, intellectual work that Einstein was doing. If you consider his personal life or his family life, it was not a very smooth affair. He had a lot of problems, but and he migrated to several places initially. After getting posting in the clerk as a patent office, he got recognition in 1905. He was offered a post in Austria as a lecturer in physics. There he joined. He was there for a short time. Then from Austria, again he got a post of lecturer in Switzerland at Bern. So he came to the place where his family was there, and he was working from some time at Bern. Then Einstein was more fluent in German, his mother tongue, than in any other language. Of course, he had a good command of, fairly good command of English and French, but he was at home in only Germany. So he was offered a post later in Germany, and therefore he went back to Germany. So you will find that those days they were migrating from one, but of course in Europe, if you consider all the state, whether it is Switzerland or Italy or Europe or France, it is just like different states in India. You will find that just as we move from Madras to Karnataka or Kerala or Maharashtra, it is just like that in Europe, but they are all different countries with different languages, different culture. So actually again you find he was offered a very good post at a research institute, top research institute at Germany. So he migrated there. All during this period, he was doing a work, his family was there, he was going one place to another, but his theoretical work continued uninterrupted, and his fame and name was growing so much. But one particular issue or one particular thing you have to note about is that he was always on lecture tour, going around and explaining his theories. Though it is more than 100 years, even now you will find that how many have actually understood Einstein means it's very little. You can write the equation, you can explain it. But what is that Einstein's theory? What is that E equal to mc square? And why Einstein is considered to be a genius? There are so many other Nobel laureates who got twice. If you see Marie Curie, she was awarded twice. Linus Pauling, he got twice. John Bredin, he was awarded twice. Once for his transistor discovery and another Nobel Prize for Bose-Einstein condensate, which was referred by the scientific officer. He was awarded twice. But all of them are not considered as genius. Though Albert Einstein got Nobel Prize once, he is still considered to be a genius and an excellent person. Now, what is that and why he is considered like that? Now, here I would like to digress into the what actually that Einstein did and in what way it differed from the earlier theories or earlier beliefs in science. Newton, of course, formulated that first theory, and he made it very systematic in his famous book, Philosophy Naturally, Principia Mathematica. He did all this gravitational theory, Newton's laws, and all the other laws which are valid even today. That was valid for around 200, 300 years. But when Einstein came into the picture, first the quanta came, that is energy being made into quanta, and then this theory came, theory of relativity of Einstein. What is this theory of relativity of Einstein? Earlier to him, in physics or in science, there are four fundamental things. Mass is there, energy is there, space is there, time is there. These are all considered independent variable. If you ask me what is time, basically in science we are having two types of time, solar time and sidereal time. And what is time? If you are asked to define, the most simplest definition is that it is an interval between two events, sunrise and sunset. There is a gap. Then that particular gap, you call it as a time. What is that time? Solar time. What is a time gap? You call it as 12 hours. Then there is another time, lunar time. What is that lunar time? Rise of moon and setting of moon. The moment you see the moon and the moment the moon disappears. That is called lunar time. And then there is another one, sidereal, based on star. Appearance of a particular star, disappearance of the particular. You are not able to, it doesn't disappear, you are not able to see. These are two events, appearing and disappearing. You are able to see or not. What is the interval or gap? That is called as a time. And then that is supposed to be independent. That's what Newton said, and that is what every person, even today, believes. And another thing, space. What is space? Suppose you take the paper or anything, it is two-dimensional. You will say length and breadth, and you will be able to fix it. If you go through a three-dimensional object, say for example a block, a rectangular block, you require length, breadth and height. There will be three dimensions. Therefore, it will be called as three-dimension space. So maximum in space means three dimension. Newton said that it is independent. Time is independent. Then what about the next thing? Mass. Mass is independent. Then what about another thing? Energy. You have got a different type of heat energy, light energy, sound energy. He said all of them are independent. Therefore, in science, according to Einstein, and even now, predominantly everybody believes that all these four, mass, energy, space, time, they are all independent. And that is very common sense, and also you can easily explain. But when Einstein came into the picture, and when he started to explain certain theories, what he did and what his contribution is that he said that space and time, they are not independent. Space and time, they are always combined together and they are inseparable. It is a continuum. So by common sense, you will not be able to judge what is this combination, but that it is a fact. There are indirect experiments to prove what Einstein said, it is correct. But many, even today, will not be able to imagine or conceive that how space and time can be made into one. But that is a fact, it is a reality, it has been verified several times in several ways. But they are all not easily understandable and easily expressible. But you have to require a lot of imagination. Similarly, what Einstein did, you will find E equal to mc square. E is energy, m is mass, c square is velocity of light. So what he has made is that the four parameters, mass, energy, space and time, he made into two. What he said, mass and energy, they are one and the same, interchangeable, you can pair them. And what about space and time? He said space and time are not independent variables. They are combined and they exist only as one entity. Because we are conditioned, because we are thinking from the beginning, space is different, time is different, we are living in this world. But he says it is not so. So many were not able to understand. And so he went on a lot of lecture throughout Europe. He went to Japan and then again to USA, everywhere giving this lecture. And you will find all, in spite of his giving several lectures, everybody had a doubt. He was repeating with the same words. And remember, Einstein was not a very forceful way of putting things. He was very good at Germany, but not that good at other languages. So he was faltering. And there is also a famous story. I don't know how many may be knowing. Then when he was traveling to Europe, he was giving at University of Paris. He had to go, next appointment was at Paris, and he had to give a talk on relativity on that particular university on that day. He was going through and his driver also was there. And his driver said, "Sir, you are professor, you are repeating the same thing everywhere. You are having difficulty with French. Why don't I try the next time, because almost I have mastered all your way and I can talk better French." Einstein was not famous at that time. So what they thought, okay, you can try. I will be going there and sitting at the back like a driver, you give the lecture. So in Paris, that is in the early 20s, that driver gave the lecture because verbatim he was repeating the same thing. This driver went on and he explained, and in very good French, the whole lecture, and it was all success. Then they were asking the same question, a few standard questions. He was able to explain them. Then suddenly one person asked one very sensitive question or a different question, which the driver could not answer. He did not, because earlier nobody asked it. Then, but he was a very intelligent driver, I think. He said, what such a kind of very basic question you're asking me, even my driver can answer it. And so he made, and of course Einstein can't reveal I am the, so you got up and in faltering French he was able to explain what is the answer for that. And then he came out. And then Einstein congratulated him and said, you are really very intelligent. You are able to perform or deliver it in excellent French, which I cannot do. So what is the position today means? Today also it is that. A lot of theories, equations you can understand. But what actually Einstein means, he has said elsewhere that it is more through intuition, through thinking, through imagination. And whenever he was felt stressed, he used to go to take to music. He was an accomplished violinist and his mother was a violinist. So whenever he couldn't solve a problem, Einstein has said, I will be playing music. So when he was playing a music, he will get an idea. He'll come down and he will immediately jot down and he will get it done. So like that, he has said that all my ideas, I got it not through rational thinking. It was all done through intuition, but I will make it or I'll put it in a mathematical frame because he was so good at mathematics. He was able to translate the intuitive ideas into mathematical formulas, for which, of course, science is made up of mathematics and formulas. He was able to translate it. And he was called a genius only because of it. And I was telling you, he made space and time into one, mass and energy into one. Everyone, even nowadays, even a school student knows E equal to mc square. And of course, that is the basis for the atomic bomb also. But Einstein, when he discovered or wrote that equation or was able to find it, he never thought. But later, of course, it was applied. They found that mass is so much of tremendous amount of energy that it can be converted from energy to mass. But at that time, he was not aware. So what is, you will, running matter, written matter or Manhattan, what is Manhattan project for title? இது அப்புறம் வரேன் மேன்ஹாட்டன் ப்ராஜெக்ட்னு ஒன்று வரும் பாருங்க டைட்டில் மேன்ஹாட்டன் இன்னும் போங்க ஒன்றும் இல்லை அதில் போகும் அப்புறம் இன்னும் அப்புறம் இல்லை முன்னாடி இங்கே போயிட்டு மேன்ஹாட்டன் ப்ராஜெக்ட் actually you will find America was able to outwit Germany because Einstein wrote to the president that for the reasons of security, America has to spend a lot and go ahead in this project. A lot of money was spent. And so later there was a lot of inquiry. Even Einstein was subjected, whether he was involved in all these things. He has said that apart from writing it, I have got nothing to do because he is not at all an experimentalist. He was only a theoretician. He had no knowledge about it. In fact, this entire project was handled, operated and finished successfully by another equally well-known Nobel laureate in physics, Robert Oppenheimer. He was responsible for the project along with some other person, Chadwick and others. But the American Robert Oppenheimer was the key person operating it. But a letter was suggested recommending that it was an important one to the President Roosevelt. And so they were able to develop the atomic bomb and stop the course of the Second World War. But popular conception is that Einstein only made this atom bomb and E equal to mc square. It was prevalent then in America and even now in many places, but it is not so. In fact, he has said that had I known about all these things, I would have said never drop a bomb. It can be prolonged some other way. But of course, the potential of that equation E equal to mc square can be given a real picture by seeing this atom bomb. See what you are getting. Now, you will find, now I'll tell what is this condensation or reduction of this 4 into 2, I have said pair, physical pair, mass and energy, space and time. So based on that, another one more idea of Einstein, which is still valid, verified experimentally, was that Newton and others, and even now everybody believes, anything can travel at any velocity. If you give more energy, it will travel at a higher speed. But Einstein has found a miracle number called as the velocity of light, 1,86,000 and odd, or 3 into 10 power 8 meter per second. He said nothing can travel greater than this. Before Einstein, there was absolute, even now, everybody thinks you give more energy, it will go travel faster and faster. You press the accelerator, the bus will go faster and faster. How much speed? As you are able to press, as you are able to give energy. But Einstein said that nothing, whatever energy you give, you cannot exceed that velocity of light c. It becomes a universal constant. And so what happens if you are going to travel closer and closer to the velocity of light? You will find that the mass of the particle will increase. Newton said mass is a constant. Einstein has said mass is not a constant. Most of our phenomena, our laws are involving matter traveling at ordinary speed. There you will find mass is constant. It is not constant. There is a very slight increase, but the very slight increase you cannot detect it, so you think it is constant. But the fact is, it is not at all a constant. When a body is moving, its mass will increase. When a body is at rest, it will have what is called as a rest mass. If it starts to travel, its mass increases. But you will not detect it because it is a very low speed. Go to the velocity, half the velocity of light or 3/4 the velocity of light, the mass will become 1.5 times or 2 times and will require more and more energy to increase the speed. As you become closer and closer to light, you will find that you require enormous energy. Otherwise, it will not move. So it was proved. Because at later date, we are able to experimental techniques, experimental methods increased, and it was proved beyond doubt what Einstein said is correct. Velocity of light is the fixed one. It can nothing, no body can travel higher than the velocity of light. There was another theory given by our own scientist E.C.G. Sudarshan, who developed another particle called as tachyon, and he said it will travel always above the speed of light. But that theory was not accepted because it could not be proved. So what Einstein said, up to now it is valid. Nobody can disprove it. தெரியாதா தெரியுமா? Now coming to more of his about the contribution. First, I told a special theory of relativity. What is special theory of relativity? In the special theory of relativity, which he published in 1905, which is more than 100 years now, what it states, you should not take into consideration acceleration, that is no gravity. You should not think about gravitation existing there. Then it is called as an inertial frame. So you will find in inertial frame means a frame in which there is no acceleration. Then how a particle will behave, how it will have repercussions from the earlier transformation. Earlier transformation of Newton and others is called as a Galilean transformation. And in the Galilean transformation, you will find that there is no change because mass is a constant. You find that as you go from one frame to another, that is from one speed to another, nothing will change. But according to relativity, because you are able to limit that velocity at the velocity of light, you find that when you are going from one speed to another speed, the mass factor will be going on changing. Time factor will be going on changing. Therefore, from one place to another, if you switch, of course, you should be in a constant motion. There should be no acceleration. Then you will find mass will increase if you increase the velocity. Time will dilate. That is called time dilation. When you are going to travel at a different speed from one which is at rest, or relatively they are at different speeds. This, of course, is very easily said, but to understand it is not that easy to digest it and to believe it. And so nobody believed what this Einstein is telling. It is something not acceptable. All are traveling. I am traveling in bus. I am traveling in a jet or another in a car. There is no change of time. There is no change of mass. We are all same. But this cannot be observed when you are traveling at a very small speed or even at 100 kilometers. It cannot be observed because velocity of light is 186,000 miles. So only when you are going to have 50,000 kilometer or 50,000 miles or 1 lakh miles, that change can be observed. Normally, even today, human beings or machines or rockets don't travel at that time. Then how they were able to prove or how they were able to say that what Einstein said is correct? Experiment based on cosmic rays or on accelerated elementary particles. Electron, proton, neutron, all of them will travel at very high speed. So by doing experiments at microscopic level, at this atomic level, mass was traveling at a very high speed. They were able to prove that. Yes, what Einstein said is correct. From cosmic rays, you are getting several particles. Pi meson, mu meson. So when they are coming down at a tremendous velocity. So they were able to observe the mass. And there are different types of chambers, devices. They are called detectors. Wilson cloud chamber. Like that, we have got so many other chambers or devices, a GM counter. So using all that, lot of scientists throughout the world, Einstein gave scientists a lot of work. He made something on the paper. But for that verification, hundreds of scientists throughout the world with all this apparatus they were doing with the detectors. And it was proved what he said, that when the velocity of the small particle is tremendous, their mass is increasing. And according their decay time also is changing. It has got a lifetime of 5 milliseconds. If it is traveling at a very high speed, it will go to 10 milliseconds. You reduce the speed, it will live for a longer time. So actually, what Einstein said in the special theory of relativity, most important thing is that 4 dimension. Don't separate space from time. Space and time is a continuum. So using that, they found that it is not at all what he said is correct. You can't do it at the gross level or at the big object level, but at the smaller level it is possible. Just like in the case of all experiments, first they do it in the case of rat or in the case of thing, only then they come to human being. Like that, in the case of small particle, it is verified. When it comes to human being or bigger object, you can't have machines and you can't have accelerators to go to that speed, and you may not withstand that speed. Therefore, this theory of relativity, special theory of relativity, wherein gravity is not considered, is verified several times and proved to be correct. And therefore, when it will come to the gross level, means it may not come, because we may not travel at that speed, objects cannot travel at that speed. But when you go down to that smaller level, microscopic level, you find that only you have to apply Einstein's laws, Einstein's equation, Einstein's transformation, only then it will give the correct result. If you apply Newton's equations and Newton's, you won't get the correct one. So what is the utility now? We are sending man and others to the space, to the moon and to the other planets at very far away, and you are doing some experiments relating elementary particles there which have got tremendous speed. So for all that, Einstein's theory is used, special theory of relativity, if it is done without gravity. Then what happens when gravity comes into force? You find that Einstein generalized it, and that is called general theory of relativity, and he published it in 1915. When you come to that general theory of relativity, so far all of us are using a geometry called as Euclidean geometry. What is that Euclidean geometry? Everybody will know that three sides of a triangle, if you add together, it is equal to 180 degrees. That is a basic thing and is a type of geometry everybody is aware. But when it comes to general theory of relativity, Einstein used tensors and another geometry, non-Euclidean geometry called as Riemann geometry. What is that Riemann geometry? In a Riemann, it is dealing with curved spaces, curvatures, and there the three angles of a triangle will always be greater than 180 degrees. It can never be less than 180. It is a separate geometry that is not commonly used. Why Einstein used? The reason, Einstein said, whenever there is a huge mass, you will find, and ஒரு படம் ஒன்று ரவுண்டா இருக்கு காட்டுங்க, பால் மாதிரி இருந்து பாருங்க, ஒரு முதல்ல வந்தது ஒரு மெஷ் மாதிரி இருக்கும். ஒரு முதல்ல எல்லாம் போட்டுருக்கீங்க. No. You will find in this there is a sort of a mesh and there is a ball at the center. What does it mean? It is the space. Actually, it is called, there the lines, they are not straight lines, they are called geodesic. And in this particular kind of space, three angles of a triangle will be always greater than 180 degrees. In general theory of relativity, what Einstein says, space is a curvature. How it will be bent? Depending upon the mass where it is. Suppose you take sun, the space around the sun, there you have to imagine the sun, and the space around the sun you will find is curved, because that enormous mass is spending the space there, space-time continuum, in fact you have to tell. He says there will be a lot of curvatures, but we imagine that space is something flat. He says it is not so. Everywhere, wherever that kind of curvature, you will be able to find or detect only when enormous mass is there, like the earth, like the sun, like the black star, like the galaxy, you will find there. Lot of curvature undulations are happening, but you can't see with the naked eye. If you see with the eye, if you see with the common sense, you cannot see. He says that it is bent, and his equations using tensor and Riemann geometry arrived at some particular value for this bending. In the next slide, ஒரு star மாதிரி காட்டி ஒன்று இருக்கும் பாரு. You will find here, this was an experiment performed by Arthur Eddington in 1919 during Second World War. to verify what Einstein said. It will be totally unrelated, but how it is happening. That yellow thing is which you see is the sun, and there is a star behind it, and there was a solar eclipse, and therefore the sun will get cut off, light will be there visible. So what happened? The actual star is there. Light has to come straight and to the particular universe. The earth is there. But you will find, according to theory, Albert Einstein predicted that there will be a bending of light. Why the light bends when it comes close to the sun? Because there is a curvature in the space near the sun because of its enormous mass. Therefore, light ray from that star will not travel straight, but it will get bent and it will come there. By how much degrees means it is very less, very, very less, half a degree or some particular fraction. The detail is there. I am not going to do it, go into that detail, but you will find in the picture there is a bending. He said light will be bent by this. You can measure the deviation from the straight to the angle through which it will be bent. This was actually done by the famous British astronomer Arthur Eddington in 1919 by going in a ship during the World War time just to see, because in 1915 it was predicted, 1919 this kind of solar eclipse happened and he had it sponsored and it was done and he was able to measure. You will find there. See how from the apparent location the straight and from the actual thing the deviation. If you draw a straight line, it has to go there. The star has to be there. But the star whose location will be known from this cosmology where all the stars are located, it is actually there. Therefore, light has, instead of traveling straight, it is getting bent and coming here. So this prediction of Einstein was verified, and therefore they said what Einstein has said is correct. Space is curved. But even today, if anybody says, or if Einstein says, many are not prepared, we are not able to, our common sense won't accept. Even at that time, whenever he lectured, he was asked a question. All will be there after that. What is the meaning of relativity? Actually, Einstein has written only 3 or 4 books. Actually, 2 books. The first book, The Meaning of Relativity, written by him. It is only a collection of papers delivered on the lectures delivered by him at US. That is the first book published in 1921. And the last book, and of course, the last book which he published was The Evolution of Physics in 1935. That was also authored along with him by another scientist, Leopold Enfield. Both of them wrote that Evolution of Physics. Those were the 2 books written by him. And there is Scientific. And there is another book. Of course, that later, that detail you will see there. One is The World as I See It. That is also purely a collection of essays which he has written at various times. That was put into a book and it is there. And then there is another one which was also written at various times, autobiographical notes, and it was compiled, edited by an author wherein all famous scientists are there. That is also there. These are the famous books or popular books which was written. All others were only lectures and essays and correspondence done by Einstein. So now coming back, what did Einstein say whenever people asked him, how do you explain relativity or how do you explain all these curvatures we are not able to see? So in his own words, what I say you will find in the book, The Meaning of Relativity by Albert Einstein, first published in 1921, wherein he has said the most common way, in a popular way if you want to understand, first you have to understand what is meant by a galaxy. In what galaxy? You will find here, with this I'll conclude. You will find first is Einstein, first is Newton, the second one is Einstein, and the third one is Vedatri Maharishi. He is a contemporary, of course, he is no more. He is a person of Indian origin located at Tamil Nadu only. Why I have put him? If you read that, you will be able to know. You will find why I am taking all the 3 to compare. Einstein, as Newton has said, mass is a constant. You will find Einstein has said mass is not a constant. M equal to E divided by C square. And this particular part, now he has not said that, but actually one of his disciple by name Alagar Ramanyam, he was a professor of physics, he retired as a principal. Recently, I had occasion to attend the launching of the book, which is called Physics Redefined, Beginning from the Beginning. In fact, I have taken it only from that particular book, a comparative of that statement. You will find that generally over in the entire science so far, Newton said space is vacuum. Einstein has said space can get curved by the presence of a mass, that is a massive object. And you will find, based on this philosophy, this Dr. Alagar Ramanujam, who got his doctorate in physics from Madras University, and Dr. Matthews in nuclear physics, he has done a lot of work and he has published Space is of Consciousness and Energy. It is his concept he has derived and he has written a book. And of course, mass you will find according to Newton, m is equal to F by A, Einstein, m equal to E by C square, whereas according to him, it is m is equal to beta into A into C minus R. You will find consider space, time, matter and energy as independent of each other. This is what I have already told. Considers only two independent, according to Einstein, space and time, continuum, mass and energy combined. Whereas here you will find the latest, space alone is the basic one. Of course, the other things are there. I am not going through, you can see. I'll, instead of reading all that, it is there on the slide for you to see. Why I want to tell that? This particular person, how he has arrived at it based on his guru, that Vedatri, by intuition, just like Einstein got by intuition, he has said that space is fundamental. All others are next. Only from space, all mass comes, energy comes, space comes, time comes. He says of the four, take space as the basic one. Of course, that is not proved. In fact, he had correspondence even with one Nobel laureate called Jim Peebles, Jimpeebles, and he has also said it is good to think old ideas in new direction as you are doing. But there inevitably a low chance of success because there are so many directions to search. I send you my best wishes for your direction. Jim Peebles, he was a Nobel laureate who has responded to his ideas, and that particular equation, m equal to beta into A minus C minus R, has got lot of values and constants, and C corresponds to consciousness, beta is a constant. And I cannot dwell in this particular short time into all the details of the formula theories. But I would like to conclude to say that Einstein's theory or Einstein's idea, what he put forth in 1905, is still very much active. And Einstein's most famous statement was the most incomprehensible thing about the universe is that it is comprehensible. But the way in which quantum mechanics are developed, you find that it becomes incomprehensible. Why? Even before he died, in 1955, there was a series of correspondence between Newton and another famous scientist, Niels Bohr, and his son, Aage Bohr. They were located at Brussels. It is called Copenhagen School of Thought. And Einstein was in Harvard, 55, and as the senior scientific officer was telling, he was about to die in a day or two. But even then, in the Physical Review 1955, if you refer, there will be a series of correspondence. The title of that will be, Can Quantum Mechanical Description of Reality be Considered Complete? Einstein says it is incomplete. Whereas the Copenhagen School of Thought, that is Niels Bohr and others, say it is complete, it is like that. And therefore, that what Einstein till the end wanted to prove was that science is very deterministic. Everything can be decided. But Copenhagen and Niels Bohr said that it is not so. Reality is only like this. So that his efforts to bring about the unified theory, Einstein was not able to do. Stephen Hawking was not able to do. So many theories are there. And in that line, you will find that Dr. Alagar Ramanujam, by the inspiration of his guru, who said that space, he also has said, I feel that space, I felt that in my intuition, space is the basic one, not mass. Science considers, and so many are considering mass as a basic. He said, no, not even mass. Space is the basic. and he had developed some equation and theories and also published it. And as late as you will find in 1919 also, a lot of publications have come, but still it is a open one because it has not been accepted or experimentally proved. Therefore, with that, I would like to conclude and thank all the organizers and the audience for having this patient listening. And now, if you are having any questions, you can ask me.
Thank you, sir. Thank you for the excellent presentation on the life and contributions of Sir Albert Einstein. And thank you for sharing the valuable information and the rare photos, sir. Now I request the participants to pose questions to sir. Any questions, please? Any questions you can ask, or you can just type in the chat box, please. Sir, Mr. Murugan wants to know, is a German scientist or American scientist?
He is definitely a German. He acquired American citizenship out of compulsion in 1933 because Germany came under Adolf Hitler and all the Jews were persecuted. Therefore, he was was forced to become an American citizen. But one thing, all along, he was a Swiss citizen. From 1905 till his death, he held the German Swiss citizenship.
Sir, Mr. Shankar wants to know what is the current status of unification of all forces into a unique theory.
Still, it is under process. No unified theory has been successfully formulated.
So, any clarifications, please? So, we are at the end of a very fruitful session. It's time for extending vote of thanks. I request my colleague, Mr. Satish Kumar, to extend vote of thanks.
Thank you, sir. Today we are celebrating 144th year birth anniversary of greatest physics of all time, Sir Albert Einstein. On behalf of Secretary cum Chairman, Puducherry Council for Science and Technology, I thank our resource person, Dr. T. Rajkumar, retired principal, Mahatma Gandhi Government Arts College, Mahi, and professor in physics for delivering a wonderful lecture on Albert Einstein and his contribution to physics and overview. I would like to thank our member secretary, senior scientific officer who are behind the webinar for making it a great success. I would like to thank all the participants for taking the time to be here today and for listening to the whole session of the webinar. And I hope this webinar is very useful to all the participants to know about the Nobel Laureate Sir Albert Einstein and his contribution to the global society. Further, I kindly request all the participants to fill the feedback form for getting e-certificate. Thank you. Jai Hind.
Yes.